So now let's talk about our new term, covalency. So what is covalency? It is a combining capacity of an atom of element which depends upon number of unpaired electrons present in ground state or excited state of an atom of element. So it is combining capacity of an atom of element. So it is a combining capacity capacity of an atom of an element okay, which depends on number of unpaired electron in its ground state or excited states. Like if we talk about some elements, if we take some example elements, okay, now like elements hydrogen, fluorine, oxygen, nitrogen, phosphorus, sulfur. So what is the combining capacity of hydrogen? We all know it is 1. Fluorine we all know it is 1. Oxygen 2. Nitrogen 3. Phosphorus again 3, 5. 5 is the maximum covalency. It is the maximum covalency. And if we talk about sulfur, how many sulfur had? Sulfur has 2, 4, 6. 2, 4, 6. So 6 is its maximum covalency. So covalency could be 1, could be 2, could be 3. Okay, it depends on how many excited state, how many unpaired electrons in its ground state might be different in excited state. Okay, so now if we talk about some elements like halogens means like chlorine, bromine, iodine, X, chlorine, bromine, iodine. So here the covalency generally found to be 1, 3, 5, 7, and 7 is the maximum covalency possible, okay, of the halogen atoms. Now if we talk about how we can predict the covalency. So suppose we talk about boron, okay, boron. Now what is the ground state of boron? It is 2s2. If we talk about the valence shell, it is 2s2 and 2p1. It is 2s2 and 2p1, okay, and its valence shell, okay, in its valence shell it is 2s2 2p1. Now here how many unpaired electron? It has 1. So one possible covalency is 1. Now boron when gets in excited state, we can stock mark or we can write excited state. So means this electron will excite and jump to the next that empty orbital. So how now in unpaired electron it has 3. So now it has 3 unpaired electron. So covalency possible of boron is, so we can predict the covalency of boron is 3, 5 is 3 and 5, okay, because now 1, 3, okay, covalency of boron is 1 and 3. Now if we talk about one more substance, if we talk about like sulfur, okay, sulfur again we will talk about valence shell. So sulfur it is ground state, sulfur it is excited state 1, okay, when we can have maximum more possible excited state. So ground state, what is the, it is 3s2, then 3p4, it is 3s2, 3p4, and it is 3d naught, okay, 3d 0. So it is its 3d 0, 1 2 3 4, 1 2 3 4 5. So it is 3d 0, and it is here covalency is 2. Now in sulfur excited state 1, the excited state 1, now it is 3s2, we know 3s2. Now if we have excited only one electron, okay, now it is 3s2, it was 3p4, okay, now one electron get excited and jumps into d shell, so it becomes 3d3, and becomes 3d3 and 3d1 or 3p3, so it becomes 3p3, 1 2 and 3, and it becomes 3d1. Out of 1 2 3 4 5, it is 3d1. Okay, now how many unpaired electron? 4. So here covalency is 4. And similarly if we talk about excited state 2, so it is 3s2. It is again, this electron will again jump to the next possible shell, okay, so it is 1, again here it is also 1 2 3, again here it is also 1 2 3 4 5, So 5 orbit and 2 are filled. So our covalency possible is 3 plus 2 plus 1, 6. So here 6 unpaired electron. That's why sulfur we have written 2, 4, 6. Okay. So that's how we will predict about them. Okay. Now if we talk about if we talk about a new example, a new illustration, why N2 exists but P2 doesn't exist at ordinary temperature. So what you can do, you may pause the video and you may try to answer the question by your own. So now talk about why nitrogen N2 exists but phosphorus will belong to the same group of nitrogen. Okay, now why this form N2 could form N2 but that could not form P2. So let's we first write the electronic configuration of valence shell of nitrogen. It is 2s2n, it is 2s2n 2p, and it is 2s2n 2p2. It is nitrogen is 2s2 and 2p3. Okay, it is 2p3. So this is the ground state of nitrogen. Now similar to other nitrogen atom, the nitrogen atom is in ground state. Okay. Now another nitrogen atom. If we take another nitrogen atom, so if we draw the valence shell configuration, it is again 2s2 and 2p3. So now what happens? Nitrogen has actually 3 unpaired electron. So they form bond with each other. Okay. So it forms sigma and it forms pi and it forms pi. So nitrogen is in ground state. Okay, now it is the first nitrogen. Okay, now nitrogen has a triple bonding. One is sigma, rest of them 2. This is also pi and this is also pi electron. So N2 exists at gaseous state. Okay, so here N2 exists as a gaseous molecule at room temperature. At gaseous molecule at room temperature. So if we talk about the similarly, if we talk about the P2, if we talk about the P2, in P2 actually what happens? In P2 again there are P that 1s and remaining are P orbital. Okay, 1s and remaining are P orbital. So P orbital has these type of loops. Again here if we talk about P, so P orbital has these type of loops. So here one has sigma bonding, rest are pi bonding. Pi bonding means it is sideways overlapping. Sideways overlapping. So if we see about see the overlapping between the first period. Okay, if you see the overlapping in first period. Okay, overlapping in first period and second period are effective. When we jump to third period, the effective become very less effective. Okay, beyond third period, the atom in the sideways overlapping, the effectiveness of bonding. Okay, bonding effectiveness is not there. Okay, so not effective. Okay, so it is not effective. Okay, so if we talk about the sideways overlapping is not effective. So we know that the sideways overlapping here it is not effective because when we jump to third period the size becomes more. Okay, now they are become less effective as they were in second period. So that's why it doesn't exist under the ordinary condition at room temperature. So if we talk about under the ordinary condition, ordinary condition means room temperature. Under this ordinary condition means room temperature. So N2 is gas at room temperature. We know N2 is gas at room temperature and P4 is solid at room temperature. P4 is solid at room temperature. So we know that P4, again if we talk about the structure of P4, we will get like this: 1p. Okay, next P atom. Okay, we will be knowing that there will be obviously one lone pair because 2s2 electron will be there, and this type of 4p are they are bounded, connected with each other. So they are connected with each other. So it is an angle of 60 degree. Okay, it is a tetrahedron. If you say this is a tetrahedron and they are connected with each other, and here they have the lone pair. So now, and so P4 is white or yellow solid at room temperature. So P4 is white or yellow solid at room temperature. So it is white and yellow solid at room temperature. And when you break that, when you like P4, when you give heat to them, it becomes 2P2. 2P2 means it is vapor. So P2 means it is vapor, or P2 molecule exists in vapor phase. Okay, so we can say P2 molecule. When it forms P2 molecule, it exists in vapor phase. So it exists in vapor phase. So now we know that P2 could exist. Okay, when P2 will exist when you will heat them. Okay, so there is a lot of strain among this bond. The angle is 60 degree, which is a very strained angle. Okay, so strain is too much, that's why. So if we talk about the atomicity, okay, so how we talk about atomicity? So N2, what is the atomicity? Atomicity we will be answering by 2, and P4, the atomicity we will be answering by 4. So that's all the information we can take from this question. Now again we talk about one more illustration. Why M2 exists but S2 doesn't exist under ordinary condition, means room temperature. So you may again pause the video and try to answer by your own. So now let's talk about the oxygen in gaseous in the ground state. Oxygen atom is ground state is like 1s2, it is 2s2 and 2p2, it is 2s2 and 2p4, 1 2 3 4, it is 2s2 and it is 2p4. So this is the oxygen in ground state. Similarly, if we have other oxygen, okay, similarly other oxygen, if we take one more atom of oxygen, so it will be again 2s2 and 2p4. In case of 2p4, it is forming like this, and it is this and this. So we know there are two bonds here and here. So these two bonds, one will be sigma bond and one will be pi bond. These unpaired electron forms bond that we have seen already, okay, in while studying, okay, forms bond while studying the covalent bonds, okay, that forms bonds. Now if we have oxygen double bonding with oxygen, okay, so oxygen double bonding with oxygen, so it is sigma and it is pi. So that's how it works. So it exists as gas molecule at room temperature, at room temperature. Similarly, if we talk about if we see that S2, if we try to form S2 again, so S2, if again the sideways overlapping we have to consider, because obviously there will be multiple electron. So again here, if we see the S2, that becomes 2, okay, oxygen, sulfur, selenium, okay, Te, okay, Po. Okay, so we know it is second period and it is in third period. So we know that the third period overlapping is not perfect, okay, and the overlapping is not effective as we go down to the room, because size again sulfur is increasing and there is a lot of repulsion. So here sideways overlapping, okay. Here we know that P in phosphorus there could be sideways overlapping, okay, because it's from 2p2, okay, but here sideways overlapping is not possible, okay, is not possible. So here we cannot have the sideways overlapping. So as double bond as that never exists at room temperature, it never exists at room temperature. So under ordinary condition, if we talk about under ordinary condition, if we see under ordinary condition means room temperature. If we see at room temperature, O2 is gas, okay, O2 is gas, and if we see H2S, okay, O2 is gas, and if we see 4s2 is vapor, it is in vapor phase, okay, exists in vapor form. We know S2 molecule, okay, S2 exists in vapor form. So 4s2 again it forms S8 which is a solid. 4s2 in vapor. Okay, so it forms S8 is solid. So we know O2 is a gas and S8 is solid. So what is the structure of acid? Structure of acid is crown like structure exists at that exists as solid at room temperature. So if we see the structure of S8, so structure of S8 looks like this: S, then S. Okay, now again the S here and S here. So again one S here and one S here. So again this S and S. So that's how the structure looks like. It looks like 1, 2, 3, 4. Okay, so here we have a bond. Okay, 4, 5, 6, 7 and 8. So it is crown like structure. Okay, it is crown like structure of S8. A structure of S8, crown like structure of S8 exist at room temperature. Okay, we know the O2. In case of O2, atomicity is 2. Atomicity is 2. But in case of S8, atomicity is 8. So that's all the information we can take about the O2 exists because there is effective overlapping between oxygen and oxygen molecule because they belongs to second period. When it comes to the third period, the overlapping doesn't remain that much effective, or S2 doesn't form. So now let's talk about why CO2 exists and SiO2 has room temperature. We know that when CO2 is there, it is gas at room temperature. Here it is 1 sigma bond, here 1 pi bond. Here it is 1 sigma bond and 1 pi bond. So there is a very effective overlapping between carbon pure orbital and oxygen pure orbital. Again we know that it also belong to second period. It also belongs to second period. Both belongs to second period. That's why effective is very overlapping. But if we talk about the SiO2, then sideways effective not overlapping because it belongs to second period and oxygen silica belongs to third period. So there is a lot of energy difference. Okay, so the effective noise is not there in overlapping. So Si forms this type of structure which is a sp3 hybridized. So hence SiO2 is a 3D covalent solid at room temperature. Is a 3D covalent solid at room temperature. So we know SiO2 is a 3D covalent solid at room temperature because the effectiveness of overlapping is not there in SiO2. So that's why it forms this type of structure. So now if we talk about why C2 carbon ion exists, but C2 doesn't exist at room temperature. So we know that carbon in ground state is 2s2 2p. When carbon they form in excited state, this is the electronic configuration. It is 2s1, and it is 2p3. Now electronic configuration of C minus, it is okay like this. So it is again this is a pi bond and this is a pi bond. So now C and C minus, so it is C minus triple bond, C minus, it is carbide ion, and C2 minus is isoelectronic with N2, and that's why we know C2 minus 2 is isoelectronic means same number of electron that we've seen already with N2 in periodic table, with N2 and exist at room temperature. Now we have a very important note. So means what is that multiple bond cannot have more than 3 covalent bond. Okay, here multiple bond cannot have more than 3 covalent bond, have more than 3 covalent bond. So it cannot have more than 3 covalent bond. Okay, bonds when it present between non-metals. Okay, in non-metal. Okay, when it is present in in non-metal. So in non-metal we cannot exist more than 3 bonds. That's why the structure of carbon ion is C2 minus 2. Okay, so that's why C2 doesn't exist, because it is not as electronic, means it should be 4 bonds. But we know in case of non-metal it cannot have more than 3 bonds. It can go up to 4 bonds. Okay, it can go up to 4 bonds when it is present between d block metal atom. Okay, can go up to 4 bonds, when it present between d block element. So we have an example, like example we have Re2Cl8 minus 2. This is a complex ion. So Re2Cl8 minus 2. So it is Re2NCl8 minus 2. So if we see the complex look like this. It is Cl4 Re. We have 4 bonds here. Okay, then Re. It is a Cl4 and it is 2 minus. So this is a quadruple bond. Okay, so this is a quadruple bond. So it is a quadruple bond. So multiple bond cannot have more than 1 sigma bond and more than 2 pi bonds, but pure S atom always form 1 sigma bond. It can never form pi bond by sideways overlapping. So S always form, the S plus S always form a sigma bond. It cannot form a pi bond by sideways overlapping.